Hi everyone. As you all know, change is the biggest reason for network outages. In recent years, we have seen several instances where a single change has caused widespread problems. For example, in July 2024, CrowdStrike distributed a faulty update to its Falcon sensor security software that caused widespread problems with Microsoft Windows computers running the software. Similarly, in October 2021, Meta experienced an outage that took down all its services due to a network configuration change. My name is Abhinav Sharma. I'm from the PE Data Center Push team. With me, we have Francisco. Today, we want to talk about safe change management in Meta data centers. As members of the PE Data Center Push team, we understand the importance of ensuring that changes are made safely and with minimal disruption to our services. We will be discussing some best practices and strategies for safe change deployment that we have implemented in our data centers. Ever growing size of the fleet. Meta requires data centers to support the storage and delivery of its vast array of products and services globally. These data centers are essential for hosting all data services, ensuring robust infrastructure to handle the data and service demands of billions of users. As Meta's family of apps and services continue to see significant user growth, this increase in users and data traffic requires more robust and extensive infrastructure to handle the load, leading to the expansion of data center regions. Right now, with 25 data centers globally, each housing thousands of network switches, Meta is committed to providing the necessary infrastructure to ensure seamless user experiences. What kind of network changes are deployed at Meta? Meta's data centers are equipped with servers joined by network switches. These switches rely on the FBOSS service to program forwarding and routing entries into the hardware's forwarding ASIC. FBOSS works with internal routing systems such as OpenR and other software components to ensure network switches can efficiently forward traffic. We combine these forwarding binaries along with configuration for each of these and deploy them across thousands of network switches. There are several challenges for safe change deployment at Meta. Firstly, the vast diversity in network platforms across each layer results in the need for comprehensive health check strategy to detect bad changes from getting deployed on network switches. Secondly, since there is only one top of rack switch, frequent changes on these switches must be non-traffic impacting so the rack servers can continue functioning. Finally, we stick to the philosophy of release early, release often. This accelerated release cycle increases the likelihood for a faulty change to be deployed and affect the health of Meta's suite of applications, including Facebook, Instagram, and WhatsApp. Therefore, we must execute these changes with utmost care to maintain the reliability and stability of our services. To safeguard against future disruptions and address the unique challenges of safe change deployment at Meta, we use three key strategies. Number one, test more, catch more, and go slow. We implement comprehensive testing and adopt gradual rollouts to minimize risk and ensure stability during the deployment process. Number two, keep it safe. Network Health Service is a centralized system that ensures the reliability and safety of network operations across various domains by aggregating health check signals from different sources. Number three, limit the blast radius. This approach ensures that if an error or failure occurs due to the change, it affects only a limited portion of the network, preventing widespread outages and minimizing potential damage. Now, Francisco will explain each of these in more depth.
Thank you, Abhinav. Hello everyone, my name is Francisco Bautista. I am a production engineer and I work for the DC network push team in Meta. So next I will talk about how we are doing testing or qualification for the rollout process, as well as how we are doing the rollout process on the network. In terms of qualification, the EBOS system is a collection of binaries that is developed by different teams. Each of these teams will land their changes to add new features or to make changes to the binary. And each of these binaries have different purpose for the EPOS for range stack. Some of the binaries will control how we program the ASIC, other binaries will control router protocols, and then there is other binaries that control the transceivers or optics that help us interconnect the devices. Once these changes are landed, the process starts by testing this for each binary. So we do unit test or initial testing. We also do some stress testing to make sure that there are no regressions. And then once all that testing for a single binary is completed, we bundle all these changes into a single binary or bundle that we call. And then this is the bundle that will go through the more thorough qualification process that we run. In terms of the qualification process, we start with configuration testing. So each of the binaries will have a configuration, and we want to make sure that this configuration is compatible with the previous and the new version of the software. Once this configuration testing is completed, we go into integration testing. In the integration testing phase, we make sure that each of these binaries can work together as a single system, as well as they can work in the different platforms we have in the EPOS ecosystem. Finally, before we make bundle ready for rollout, we'll go through a canary phase. The canary phase will test these changes against live devices or production devices that are passing traffic. And this is the initial testing for us to make sure that the changes that come with this bundle are not going to impact the production network. Once we finalize the canary process, we are ready to roll out this into the rest of the fleet. It's important to mention that even though this process it seems to be slow on the image, it is not really that slow. A developer will add a change today, and then their changes will go through qualification and will be ready for rollout the next day. Even though the rollout takes a little bit longer than that, but basically we are making sure that our development cycles are fast enough or go fast enough through this qualification process. Next, in terms of rollout, we use a slow roll method. So for this slow roll, we divide the fleet into different roles, and then we start the rollout in a small set of devices or a small percentage of devices. For each of these phases, we have different failure rates or failure limits to make sure that when we find a problem, we can catch that problem fast enough and prevent the problem to go into other devices in the network. So through the rollout process, the push will pause, and then will trigger a human to start looking into what caused those pauses. Once the human decides whether or not this is safe, we'll continue the rollout or cancel and start a new rollout. And then this process goes over and over until we reach the entirety of the fleet. Next, Abhinav is going to talk a little bit about how we do this in a safe manner.
Thank you, Francisco. Now I'm going to talk about keeping it safe. Centralized safety system. Recent events have shown the importance of robust health checking across our network domains. In response, we have undertaken a 2-year effort to consolidate and standardize our health checking processes. By unifying these functions into a single system, which is called Network Health Service, we are better equipped to test changes thoroughly and ensure consistency across data centers and backbones. Network Health Service functions by aggregating health checks from multiple sources, which run detailed audits and checks, ensuring that every aspect of the network health is monitored. For instance, one subsystem of NHS is responsible for running custom health checks, and similar setups exist for other data sources like network state, device configuration, and more. Now we are going to walk through a change on a single network switch and see how NHS is integrated with the push process. As depicted in the diagram, push tooling interacts with network health service at various stages. First, push tooling calls NHS at the pre-update stage to verify and capture snapshots of the device state, which will be used to compare later. Next, push tooling performs the upgrade on the switch. After the upgrade, push tooling calls NHS again at the post-update stage to run both snapshot-based checks and additional point-in-time checks to ensure that the device is healthy. Following this, push tooling waits for a 2-minute break time and then runs additional checks to ensure that the device remains healthy after the upgrade. Once all health checks pass at these stages, push tooling registers the device with NHS for extended monitoring, which involves running periodic health checks every 15 minutes to ensure long-term health. Now we are going to dive deeper into what kind of health checks are done. The types of health checks can be categorized into two groups: point in time checks and snapshot based checks. Point in time checks include BGP config validation, traffic forwarding binary uptime, and reachability of the device. Snapshot based checks include capturing the state of the network or device before the upgrade and comparing it with the state after the upgrade. Some examples of snapshot-based checks include originated routes, routing pairs, and interfaces health. In addition to these checks, NHS provides extended monitoring for devices post-upgrade. If a device is deemed healthy after the initial checks, it is registered for extended monitoring, where health checks are run periodically to ensure that the device remains stable over time. NHS also offers network scope monitoring as a key feature. It periodically monitors the health of all network scopes, such as data centers, pods, and regions, using different production monitoring signals, and logs a network scope if it becomes unhealthy. This acts as a dynamic feedback loop for the health of the current push and acts as a second line of defense if device level health checks do not detect the bad change. Some changes are more risky. To address the issue of misconfigurations in routing policies, we created an emulation based system to verify routing configurations. This system thoroughly verifies every routing change by employing an emulated network across different regions, closely replicating packet forwarding paths from one rack to the other. This ensures the accuracy of every routing change and prevents config changes that do not align with the operator's intent. We also designed a specialized system to monitor and ensure the health of the control plane within a network. The control plane is responsible for routing and managing network traffic by deciding where data should be sent. This system aims to detect and address issues in the control plane. The key functions of this system include visibility and alerting and device level monitoring. Now, Francisco is going to explain how limiting the blast radius helps us in improving the safety of change deployment.
Now let's talk about how we are limiting the blast radius of these network operations or network changes in our network. This is going to talk about what we do in terms of policy. So, given the growth of our network, we come up with a policy that humans can understand. This global network touch policy is something that is network infra-wide policy. So this not only applies to the data center networks, but also to the backbone and optical networks. The purpose of the policy is to set guidelines so that our teams and operators have safety in mind when performing their work. This also help us. We also working on visibility, which help us know how far are we from the goals of the policy, and as well help us provide visibility into this to the rest of the organization with the aim to address some gaps that we encounter. As part of this effort, we have also developed some tools that help us enforce the policy at the system level so that systems can integrate with these other systems or tools or libraries that can help them decide whether a certain operation is safe or not to perform at a given time in the network. Some of the things that we did so far. So we are limiting the access to network devices for automation systems. We understand that some automation systems will not require full access or root access to the network devices. So we are limiting the access to these systems to only the operations that they need to perform. As part of this, we are also working on limiting how much capacity we can remove from the network at a given time. The way this works is whenever there is a new operation that needs to take some devices or links out of the network, we'll check on the current network status, and then using some limits, we'll decide whether or not removing this device or this set of links is safe to do at this time. Once that happens, the system will be able to either remove or will need to wait for the next cycle in order to perform the operation. We're also working with our partners into ensuring that every change that goes into the network has a safety check attached to it. So we want to make sure that we run safety checks before making a change on the device, also after we make a change on the device, so that the device or the network is healthy after the changes are pushed. Finally, as I mentioned, we are providing some visibility. So with this, we are auditing what's going on. We are also working with different teams to close any gaps that we encounter along the way, with the aim to be able to update the policy or update our limits and so on, so that operations are also not blocked unnecessarily through their life cycle. Now, what is next? So, as we already mentioned, safety is no longer optional when performing operations on the network. We know that our fleet is going to continue to grow. With this growth, we are going to see a need for more health checks to run. So we need to scale our health check and safety process. The idea is to make this process robust enough so that we can minimize the risk of downtime in the network. Finally, we also want to collaborate with the industry partners. So if you or someone you know is interested in this topic, feel free to reach out to me or Abhinav. We'll be pretty eager to work with you into how we can make this a more standard process across the industry. And with that said, I want to thank you here for taking the time to looking at this talk with me and Abhinav, and I'll see you in the next one.